All right, I'll just wait a couple minutes while a few stragglers come in. Can everyone hear me okay? Through the mic, yeah? Too loud? Okay? Good. I'll wait a couple minutes and then we'll get going. You can keep talking. Okay, I think we'll get going. I'm just trying to work out how to use this room. There's screens everywhere. I don't really know where to look, but anyway, it seems like you can look anywhere and see the screen, which is good. Okay, so I'll just introduce myself first, and then today's lecture is really, I'm just going to tell you a little bit about what GIS is and what we're going to do in the course. So it's a fairly gentle lecture to start with. So I'm Jonathan Rhodes. I coordinate this course, and I teach right through the course, so you'll see me every day for the next 3 weeks. I don't know whether that's a good thing or a bad thing, but you can tell me at the end of the course. And so I'm a academic in the School of Earth and Environmental Sciences, and I'm a landscape ecologist by training. I work a lot on environmental management problems and conservation problems. I'm really interested in spatial aspects of decision making. You know, questions like where to conserve species, where to do different actions to get the best benefit. I'm also interested in how efforts to conserve things like biodiversity and environmental values trade off against other societal values like economic costs and other societal values, or social and economic values. So I do a lot of work in that area, and I think, and the reason why I teach this course is because a lot of the work I do is spatial, and I use GIS a lot. And I've used GIS for a long time, and lots of the work that I do just simply couldn't be done without GIS. So hopefully, those of you who haven't done GIS before will, once you've done this course, will feel the same, that it actually opens up a lot of doors in terms of the types of things you can do in your future careers, and so that's why I'm interested in GIS, and so hopefully we can get you started on thinking spatially and using GIS to answer questions that you're interested in. So who here? So anyway, that's my background. Do you have any questions for me? No? Okay, that's fine. I didn't necessarily expect any. So I guess some of you would have done some GIS before and some not. Has anyone done any GIS? Who's done GIS before? Okay, so maybe about a third of you have done some GIS before, and perhaps the rest haven't. So essentially, we assume that actually you know nothing about geographic information systems or GIS. So we start from scratch. So if you've done some GIS before, some of this may be a refresher. You may have done it all before. Who knows? But I think essentially we don't assume any prior knowledge of GIS. So we're sort of starting from the basics. So what I thought I would do to start with is really just tell you a little bit about what I think GIS is. I'm going to just call it GIS rather than Geographic Information Systems. That's a mouthful. Hopefully everyone knows what I mean by GIS. Well, we'll see. And so I'm going to tell you a little bit about GIS, and I guess show you some examples of uses of GIS. And so we'll do that in the sort of first bit. We'll have a little bit of a discussion after that. And then I'm going to tell you a bit about the structure of the course and how it's structured, what we aim to do, and what the activities and assessment and so on are. So, important things that you need to know. I guess this is a short, compressed course. I guess some of you have done intensive courses before, so it is quite an intensive course. I'll talk a little bit more about that later on, but it is compressed over 4 weeks, and we got 3 weeks of activities, and we got something on most days. So it's a fairly intensive course, and so that has its own challenges. I think challenges and benefits. I think there are some benefits of doing it in a compressed course, and some challenges as well. But happy to talk about that later. So let's just talk a bit about what I think GIS is, and hope, this may or may not align with what you think GIS is. But I think it's important to get a sort of understanding of what it does and why we do GIS. So why don't you tell me first what do you think GIS is? Some of you have done GIS because you put your hands up, so you must know what it does roughly. So for those who've used GIS before, how would you describe it? Yeah. Okay, good. So one person read the book. Okay, good.
So it's just like an information system that you can gather points and vectors and elevations and all sorts of things, and then you can comprise some layers.
Yep.
To see, what areas. You can use it for a lot of different things. But in conservation, you can use it to see what spaces animals are moving around in.
Yep.
You can see if there's different maybe barriers to animal movement, stuff like that.
Yep.
And use it for management.
Yep. So I think that's a reasonably good description one description of GIS. You'll see actually there's many definitions of GIS. But what's unique about that? A lot of those things you can use GIS to answer. Right. Yeah. So you can integrate things. Yep, that's one thing. I guess something more fundamental than that.
It's based on information that you actually gather.
Yep.
What you can make with it. So it's you can do a lot of different things with it depending on the type of data that you gather.
Yep. That's true. So it's really an information system. But what's I guess even more fundamental than that.
Basically, it's mapping.
Yeah.
So,
right.
Yeah, just anything for conservation-wise.
Yep.
Commercial.
Yep. So mapping. I press. That's true. It is mapping, but I think it's the way I describe it is that it deals with spatial things. So it addresses the issue of space. So by spatial I mean locations on the Earth's surface. So I guess that's the unique thing about what it does. But I think we've covered some of those aspects now. This is one definition. And maybe this was in the book. I don't know. I can't remember where I got this from. So a geographic information system is a computerized data management system used to capture, store, manage, retrieve, analyze, and display spatial information. So the key thing here is it's spatial. So we're dealing with spatial data, and that's important. And I'll talk about that some more. I'm going to. So I'll quickly show you this video. This is more. That's not good. Hold on a minute. Let's see if I can link to it. Yeah. It's a quick video from Esri. See if I can link to it now. No, that's no good. No. Okay. I don't seem to have a connection to the internet. Let's try again. See if I can get any web page. No? This is good. That's a bit weird. I'll try a different browser. Oh. This is looking hopeful. It should actually be connected through here. Bear with me. It's possible I wasn't logged in properly. Let's see. Doesn't look good, does it? Yeah. I know. I don't know why I don't have. Yeah, it's weird. Anyway, I might have to try that. It should connect through the blue cable, but I don't know why it's not. It says it's connected. It should just connect through with EduRoam. I don't know. That's a bit weird. I'll try the visitor one and see if we can get any luck. I'll try this, and when we have a break in the middle, I'll see if I can fix it. Nah. Oh dear. We'll keep going. What I'm going to do, I'll call someone to come and have a look at it for me, and we'll just keep going, and I'll play it later. I'll just call someone quickly and see if they can come and have a look. Okay, they're sending someone to come have a look. We'll keep going, and then we'll come back and watch some of these things later. Well, if we can sort these things out on the first day, hopefully it'll run smoothly after that. Okay, so let's keep going, and we'll come back and see if we can watch some of those later. That definition of GIS is really focused around software and data analysis. But actually, there's much broader definitions of GIS. And if you read the book chapter, the first chapter of the book, then I guess you would have picked up some of this. But many people describe GIS as much broader than just data and software. And actually, it's a system really that is really includes software and data. But I think these days, GIS is really an interconnected system that involves, often described as three parts to a GIS. There is the software and data, but there's also people. So there's people using GIS to make decisions. So they're using decisions to make planning decisions. They're using it to plan or implement emergency responses and so on. And so there's people involved in using GIS. There is hardware, so there's computer hardware, but there's also procedures that link. And these procedures really relate to how do we use GIS and what are the things that we do to integrate GIS into our decision making. And with modern GIS, really, these are commonly linked through a network. And as you go through the course, we'll talk a little bit more about this and these modern developments in GIS. And how really this network has really opened up lots of opportunities for using GIS in really innovative ways. Just the fact that actually most people essentially have GIS capability on their mobile phones these days, and it's really allowed the proliferation of GIS to be used by non-specialists. And so this is a much broader definition of GIS. So what's different about spatial information? So why not? I mean, we've sort of talked about GIS is really perhaps just a database. But what's different about spatial information? Why is it important? Right, so it puts data points in context. So have you got an example of that? Like a spatial context, I guess. Yeah. Have you got an example of that?
Or just like across the landscape. So you can compare vegetation distributions with climate, soil, and other things
Right.
together.
Yep. At spatial locations, different spatial locations. Yep. So that's one thing. So those, and I think what you're saying is we've got these sort of data that we can link to a spatial place and then compare them. So that's one of the key considerations. So really, yeah. So spatial data have unique spatial coordinates or other spatial identifiers. So you can actually say you can measure things at different places and then start to compare them at the same place. And then the other thing is that the relationships between objects in particular locations, or the spatial relationships, are really important. And the GIS really provides the means to be able to display those and analyze those spatial relationships. Okay. And so, a classic sort of example of that is what we call Tobler's first law of geography. Is basically everything's related to everything else, but near things are more related than distant things. And what that's really saying is that if you've got, things are interconnected. So we've got connections across landscapes, but things that are close together are sort of more connected and are likely to be more similar in general. And so this is a map of Australian fire history. And as you can see, it's not just a random pattern of fire histories. It tends to be associated with particular parts of the Australian continent. And so it says that, if you pick a site up here, you're more likely to get fire nearby than a site down here. Okay, so you've got these spatial relationships, and these spatial relationships tell you something about processes. Now, I was going to show you a short video. This is a nice illustration of a story well before GIS, 100 years before GIS was even thought of, but an illustration of how spatial relationships can change public policy. And if we get the internet fixed, I'll show it to you. If not, you have to watch it in your own time. But we'll hopefully come back to it. I won't tell you what it is yet. We can hopefully watch the video. Okay, so what types of questions can we answer with GIS? What are the types of things we can ask?
Change the landscape over time.
Yep, so we ask change questions. And why might you do that?
Deforestation would be quite topical in Queensland.
Right, yep. And that would be for just understanding deforestation or?
Policy.
Policy, okay, so policy, yep.
Legal stance.
Yep,
Things like that.
yep, excellent.
You can look for common boundaries or very interesting.
Yep, so you're thinking of,
You can, ask in a particular area what are the property boundaries or the lot numbers.
yep, so you're looking, you'd sort of, there could be an information base for people making decisions about planning, for instance, right? Yep, that's a classic example of use of GIS. Anything else? I mean, the number of the questions are pretty infinite, but.
You can see where a species is distributed and where that overlaps with human settlements.
Okay, right, yep, and why would you do that?
Firstly, to know where you might be looking to conserve, and secondly,
Yep.
What issues that might present for human-wildlife interaction.
Yep, excellent. So there's lots of real-world decision-making type things that we might use that sort of information for. And really, I mean, and GIS really helps you to start to deal with, to actually answer those types of questions. And that's, and all these questions, I guess, have a spatial component. So that's what's critical about GIS. But I guess there's probably, in a really broad sense, there's probably two types of questions we might be able to answer with GIS. One is sort of what I call sort of practical or decision-making type questions. So these are questions that inform decisions that we make. So I've got an example here. These are Australian marine reserves, and we might ask, well, where should we site our marine reserves? And you can use, if you have attributes of distributions of species, protection levels, threats, we can start to use GIS to answer those types of questions. But GIS is used for a wide range of other, applications. So you come to look at. No, I can't yet. We'll try and fix the internet quickly. Okay, I think we're up and running. Right. Where are we? Okay, I think there was a problem with the blue cable. Anyway, they're going to fix it for tomorrow, but I think we're okay for now. Since we had a bit of a delay, what I might do is I might just show you this. This is a TED Talk. It's got nothing to do with Geo. So I had a video of an Esri video, who are the people who make GIS software here, but probably doesn't tell you anything much more than what I've told you. But if you want to look at it later, do so. But I was just going to show you this story, which is a TED Talk. Nothing to do with GIS, actually, but I think it's a nice illustration of how spatial information can inform decision-making and public policy. And it's told quite well. Well, if it works, can you see anything there? If it's going to work. Okay, here we go. So it's about 10 minutes, but well, yeah, that's okay.
Families dying over the course of 48 hours of cholera alone.
I'm going to start at the beginning. As I said, this doesn't have a lot to do with GIS, but in a way it does.
If you haven't ordered yet, I generally find the rigatoni with the spicy tomato sauce goes best with diseases of the small intestine. So sorry, it just feels like I should be doing stand-up up here because of this setting. Now, what I want to do is take you back to 1854 in London for the next few minutes, and tell the story in brief of this outbreak, which in many ways I think helped create the world that we live in today, and particularly the kind of city that we live in today. This period in 1854, in the middle part of the 19th century in London's history, is incredibly interesting for a number of reasons, but I think the most important one is that London was a city of 2.5 million people, and it was the largest city on the face of the planet at that point, but it was also the largest city that had ever been built. And so the Victorians were trying to kind of live through and simultaneously invent a whole new scale of living, the scale of living that we now call metropolitan living. And it was, in many ways, at this point in the mid-1850s, a complete disaster. They were basically a city living with a modern kind of industrial metropolis with an Elizabethan public infrastructure. So people, for instance, just to gross you out for a second, had cesspools of human waste in their basement, like 1 foot to 2 feet deep. And they would just kind of throw the buckets down there and hope that it would somehow go away. And of course, it never really would go away. And all of this stuff basically had accumulated to the point where the city was incredibly offensive to just walk around in. It was an amazingly smelly city, not just because of the cesspools, but also the sheer number of livestock in the city would shock people, not just the horses, but people had cows in their attics that they would use for milk that they would kind of hoist up there and keep them in the attic until literally their milk went out and they died, and then they would kind of drag them off to the bone boilers down the street. So you would just walk around London at this point and just be overwhelmed with this stench. And what ended up happening is that an entire kind of emerging public health system became convinced that it was the smell that was killing everybody, that was creating these diseases that would kind of wipe through the city every 3 or 4 years. And cholera was really the great killer of this period. It had arrived in London in 1832. And every 4 or 5 years, another epidemic would take 10,000, 20,000 people in London and throughout the UK. And so the authorities became convinced that this smell was this problem. We had to get rid of the smell. And so, in fact, they concocted a couple of early, kind of founding public health interventions in the system of the city, one of which was called the Nuisances Act, which they got everybody, as far as they could, to empty out their cesspools and just pour all that waste into the river. Because if we get it out of the streets, it'll smell much better. And, oh, right, we drink from the river. So what ended up happening actually is they ended up increasing the outbreaks of cholera because, as we now know, cholera is actually in the water. It's a waterborne disease, not something that's in the air. It's not something you smell or inhale. It's something you ingest. And so one of the founding moments of kind of public health in the 19th century effectively poisoned the water supply of London much more effectively than any modern-day bioterrorist could have ever dreamed of doing. So this was kind of the state of London in 1854. And in the middle of all this kind of carnage and offensive conditions, and in the midst of all this kind of scientific confusion about what was actually killing people, there was a very talented, classic 19th century multidisciplinarian named John Snow, who was a local doctor in Soho in London, who had been arguing for about 4 or 5 years that cholera was in fact a waterborne disease, and had basically convinced nobody of this. The public health authorities had largely ignored what he had to say. And he'd made the case in a number of papers and done a number of studies, but nothing had really kind of stuck. And part of what's so interesting about this story to me is that in some ways it's a great case study in how cultural change happens, how a good idea eventually comes to win out over much worse ideas. And Snow labored for a long time with this great insight that everybody kind of ignored. And then on one day, August 28th of 1854, a young child, a 5-month-old girl whose first name we don't know, we know her only as Baby Lewis, somehow contracted cholera, came down with cholera at 40 Broad Street. You can't really see it in this map, but this is the map that becomes the central kind of focus in the second half of my book. So in the middle of Soho, in this working class neighborhood, this little girl becomes sick. And it turns out that the cesspool that they still continue to have, despite the Nuisances Act, bordered on an extremely popular water pump, local watering hole that was well known for the best water in all of Soho, that all the residents from Soho and the surrounding neighborhoods would go to. And so this little girl inadvertently ended up contaminating the water in this popular pump. And one of the most terrifying outbreaks in the history of England erupted about 2 or 3 days later. Literally 10% of the neighborhood died in 7 days. And much more would have died if people hadn't fled after the initial kind of outbreak kind of kicked in. So it was this incredibly terrifying event. You had these scenes of entire families dying over the course of 48 hours of cholera alone in their one-room apartments, in their little flats. Just an extraordinary, terrifying scene. Snow lived near there, heard about the outbreak, and in this amazing kind of act of courage went directly into the belly of the beast because he thought an outbreak that concentrated could actually potentially end up convincing people that, in fact, the real menace of cholera was in the water supply and not in the air. He suspected an outbreak that concentrated would probably involve a single point source, one single thing that everybody was going to, because it didn't have the kind of the traditional slower path of kind of infections that you might expect. And so he went right in there and started interviewing people. He eventually enlisted the help kind of this amazing other figure who's kind of the other protagonist of the book, this guy Henry Whitehead, who was a local minister, who was not at all a man of science, but who was incredibly socially connected. He knew everybody in the neighborhood. And he managed to track down, Whitehead did, many of the cases of people who had drunk water from the pump or who hadn't drunk water from the pump. And eventually Snow made a map of the outbreak. He found increasingly that people who drank from the pump were getting sick, people who hadn't drank from the pump were not getting sick. And he thought about kind of representing that as a kind of a table of statistics of people living in different neighborhoods, people who hadn't, percentages of people who hadn't. But eventually he hit upon the idea that what he needed was something that you could see, something that would take, in a sense, a higher level view of all this activity that had been happening in the neighborhood. And so he created this map, which basically ended up representing all the deaths in the neighborhoods as black bars at each address. And you can see in this map the pump right at the center of it. You can see that one of the residents down the way had about 15 people dead. And the map is actually a little bit bigger. As you get further and further away from the pump, the deaths begin to grow less and less frequent. And so you can see this kind of something poisonous kind of emanating out of this pump that you could see in a glance. And so with the help of this map and with the help of kind of more kind of evangelizing that he did over the next few years and that Whitehead did, eventually, actually, the authorities slowly started to come around. It took much longer than sometimes we like to think in this story. But by 1866, when the next big cholera outbreak came to London, the authorities had been convinced, in part because of this story, in part because of this map, that in fact the water was the problem. And they had already started building the sewers in London. And they immediately went to this outbreak and they told everybody to start boiling their water. And that was the last time that London has seen a cholera outbreak since. So part of this story, I think, while it's a terrifying story, it's a very dark story, and it's a story that continues on in many of the developing cities of the world. It's also a story, really, that is fundamentally optimistic, which is to say that it's possible to solve these problems if we listen to reason, if we listen to the kind of wisdom of these kinds of maps, if we listen to people like Snow and Whitehead, if we listen to the locals who understand what's going on in these kinds of situations. And what it ended up doing is making the idea of large-scale metropolitan living a sustainable one. When people were looking at 10% of their neighborhoods dying in the space of 7 days, there was a widespread consensus that this couldn't go on, that people weren't meant to live in cities of 2.5 million people. But because of what Snow did, because of this map, because of the whole series of kind of reforms that happened in the wake of this map, we now take for granted that cities of 10 million people, cities like this one, are in fact sustainable things. We don't worry that New York City is going to collapse in on itself quite the way that Rome did and be 10% of its size in 100 years or 200 years. And so that, in a way, is the ultimate legacy of this map. It's a map of deaths that ended up creating a whole new way of life, the life that we're enjoying here today. Thank you very much.
Okay, so in a sense, that has nothing to do with GIS. And it was 100 years before GIS was even thought of. But then, in another sense, it has everything to do with GIS. And the point I wanted to make from that is that actually that's sort of the start of some of the start of thinking of, spatially and thinking about relationships between data that occurs spatially. So in that case, the relationship between the pump, spatial information about the pump versus spatial information about the deaths was critical in identifying the problem, but also solving the problem as well. And I think it's often used as an illustration of spatial thinking and how powerful it can be. But I think these are the types of problems that GIS now can help to solve. And we can solve much more complex problems now with modern technology and GIS. So I think I wanted to show you that because it's a nice illustration of sort of spatial thinking and how spatial thinking can help us solve problems. So we'll keep going. Yeah. Okay. Right, so we got to about here, didn't we? So yes, so practical decision-making of questions is one. I think the John Snow example is an example of solving a problem and practical decision-making. But often we're also interested in fundamental discovery type questions. So there may be things we're just interested in understanding, and that's another use of GIS. So example I have here is, where is global warming having the greatest impact on natural systems? So it's possible we might need to know that for some policy or decision-making, for informing policy or decision-making, but there are also lots of questions that we just might need to, initially we just want to understand the system. And that's another class of problems that GIS can help solve. I think often to do this, we need to do this first. We need to understand systems. So often I think, in trying to solve spatial problems, we often do this and then it leads to this. But there may be some aspects where we have that understanding, we're really just trying to solve the decision-making problem. So, some lists of examples of types of questions that GIS can solve. These are just some examples. We can ask questions about location. We can say, where is the nearest park? We can ask questions about patterns. Where do high concentrations of students live around St. Lucia, for instance? We can ask questions about trends. We can, how fast and where are glaciers retreating in the European Alps? We can ask about conditions. Where is the flat land within 500 meters of a watercourse? Something we might need to know if we're planning urban development, for instance, within, close to a watercourse. These might be areas we might want to exclude, for instance, or include in that planning process. We can ask questions like implications, so we can do scenarios. If we build a theme park here, what's the likely effect on biodiversity or social cohesion or anything like that? So we can we can ask a range of types of questions. But what do you notice about all of these questions? They're spatial. Almost in every one there's a where, isn't there? Well, almost. Here, where. There's something spatial, okay? So they're all asking spatial questions. And that's what GIS allows us to do. Okay. I thought I'd just give you a quick overview of the history of GIS. And just to give you a bit of context for where GIS came from. So basically the first GIS was the Canada Geographic Information System, which was designed in the mid-1960s, and so it was really what the challenge they wanted to solve was that Canada wanted to inventory its natural resources, and Canada's a big place. It's not there were challenges in trying to estimate area of different natural resources, and so they developed this computerized system, essentially a database. And the thing they really couldn't solve, or was very time-consuming at that point, was calculating areas of things. So really, a major advance in computerizing an inventory of natural resources was calculating areas. I'm not going to show it to you, but there's a video here which basically has a it's a video from the 1960s. You can see it's very dated, but really explains the origins of GIS and what for the Canada Geographic Information System, why they developed it. What was the driving force behind developing that innovation? And as I said, it was really just the time-consuming task of inventorying, something like that anyway, making an inventory of natural resources and being able to calculate areas and basically do accounting. So that was really just an accounting tool, essentially. And so then there was bursts of innovation in the US. They developed some technological ways of representing road features, and calculating lengths of road and so on. And so there was a burst of innovation there. And then later on, there was really, I guess, a drive for maybe in the 60s or 70s and 80s and onwards, an innovation through remote sensing, so often driven by military advances. So that allowed remote sensing from satellite imageries and airborne sensors allowed the development of larger databases and collection of information. And a lot of that technology drove further developments in GIS. I guess there was a simultaneous innovation within sort of cartography, so creating topographic maps and so on, and there was a drive to digitize all topographic maps. But that took time, and it's only relatively recently that a lot of countries have actually digitized all their topographic mapping. And then I guess from sort of maybe the 1980s onwards, the GIS started to become more commercially viable, and the Environmental Systems Research Institute created a commercially viable or commercially usable GIS software, and the GIS software you'll use in this course is the existing version of that software, ArcMap. And so they drove a lot of the commercialization, and then it's sort of developed from there. And it talks about this in the textbook if you've read the chapter. But modern GIS is very different to the very specialized software of the 1960s and 70s. And so we have GPS, we have satellite imagery, data's much more freely available over large areas. We have handheld GPS devices, which has made a huge difference to the portability. And we're often connected through networks. And we'll talk a little bit more about this later on in the course. And some of the challenges and opportunities for use of GIS across a broad range of disciplines. So I'm going to just have so any questions about that stuff? I mean, that's really just a really quick overview of GIS. And so hopefully that gives you a sense for what GIS is and what it's used for. Any questions? All good? So I'm just going to give you 2 or 3 quick case studies, examples of the use of GIS. They're all, a little bit different. And so this is the first one I was going to mention was this is a conservation planning. So this is a conservation focused, a biodiversity conservation focused project in the Solomon Islands, run by the Nature Conservancy, and really they were interested in using GIS to try to identify the priority areas for conserving key biodiversity in this island, Choiseul Island in the Solomon Islands. So it's got some of the last remnants of lowland rainforest in the Pacific, so really sort of important for biodiversity and the environment. And I think it's an interesting case study because it was really a decision-making problem, but GIS was used in a wide variety of ways. So the diversity of ways in which GIS was used is quite wide. Okay. So I guess some of the initial aspects of GIS were really about trying to map sort of values, and this project came from I guess an approach from the Land Conference of Tribal Communities in the region, approached the Nature Conservancy, which is, if you don't know the Nature Conservancy, a large global NGO focused on conservation, and really to assist them with conservation planning. And really, the approach consisted of 2 components. One which they didn't have data necessarily on all the values, and they wanted to capture local values and how people valued the landscape. So there was a 2-step approach, which was to do some participatory mapping of all your conservation values and the threats and opportunities for conserving those important conservation areas, and then using a systematic approach to identify which are the most important areas. So in some ways, this is sort of this bit here was let's try and understand the system, use GIS to do that, and this was, given that understanding of the system, what sort of decisions might we make that can best conserve biodiversity, but also preserve those values of the local people on the island as well. So where was GIS important for this? So participative mapping was basically using maps to work with local people to essentially identify and draw lines on these maps to identify where the key important areas were. And so GIS was critical for a number of things. One was just visualizing existing data, infrastructure, and villages. You can plot those on the map. Creating maps for existing vegetation. There was some reef data, rivers, roads, and major communities. And then, so that was really to give local people the context on those maps. But then, once they'd identified on those maps where the locations were, turning that into a digital form that then could be analyzed in a GIS was important. And we call that digitizing. We're going to talk about digitizing in the next few days. And essentially that's turning those lines on those maps into digital form that then can be analyzed in a GIS. Okay. So these are some of the mapped features. I'm not going to go through them, but these are just some of the areas where important environmental values were identified, and that's the GIS representation of that. And then the next stage was to take that information and then look at, well, where are the important areas? And this was what's known as a conservation planning exercise. They used this software called Marksan, which takes GIS inputs and then tries to identify important areas based on things like cost and value and so on. And so really the GIS inputs were really these conservation features or values, threats to those conservation values, opportunities, and also the cost of doing things. Okay, so I'm not going to talk too much about how that's done, but essentially there's a whole range of GIS inputs. And then from that, there was GIS allowed the visualization of those conservation areas that were most important. So I guess in this sense, the GIS was important for capturing the data spatially, It was important for doing the analysis to identify where priorities were. And that it's also important for visualization. So it's a powerful visualization tool, and throughout the course you'll work a little bit on visualization and see the different ways in which we can communicate maps. And these were the final conservation priorities on the island. And so this had an important impact. It led to the creation of 9 new protected areas based on that planning, and also has influenced government plans for expansion of settlements and so on as well. So had an important impact on policy and planning on the island. So that's one example. The other example is just the other example I have here is really just one of just understanding. This is some work of my own from a few years ago, and we've done similar work to this over the years, and I've worked quite a lot with koalas and koala policy and planning, and this is just an example of really just using GIS to understand the distribution of koalas. This specific example is a case in Noosa. So Noosa, 2 hours up the coast from here, and koalas here are threatened by habitat loss, urbanisation, the usual things, so they tend to decline. And so GIS was critical in this sense. We went out and we collected data. We actually spent lots of time looking under trees, looking for koala poo, and to indicate presence. But we had a whole load of spatial data as well. So we wanted to take our sites where we've observed and not observed koalas, and then relate that to habitat characteristics on the ground, but also in the surrounding landscape. So in the patch, the type of tree structure and the tree species, the patch sizes of habitat, and then the broader landscape. How does that influence our whether koalas occurred at a site or not? So we digitized our sites with the information on whether koalas were present or not, and then because we had that spatial information, we were able to do a thing called an overlay, and you'll learn what an overlay is over the next week or so, which basically says, well, let's look at the spatial representation of those sites and then try and intersect it with the locations of these layers of data. And then we'll try and build relationships. So we calculated some metrics, we did some statistical analysis looking at those relationships, and then some interpretation of those relationships. And so GIS was critical in this sense for actually taking that spatial representation and then using that spatial representation to try and understand the relationships between different variables at the same points in space. I guess you could have done this in a way without GIS, but it would have taken a huge amount of time. So it really saves time. And we've done lots of work like this. These are some results. I'm not going to go into this too much. This was just the bigger the bar, the more important the variable. So some of the most important things were how much habitat there was in the landscape around the site and so on. How many patches, the density of forest patches and so on. Sorry? That's I can't remember which way around it is. One of them is the independent effect, and one of them is the combined effect. So it's the total effect. I think, so I can't remember which one. I think the black's the independent effect. What it tries to do, it tries to strip out the independent effect of that variable. So they vary a bit. But that's what they are.
The question a little bit off topic, apologies.
No, that's all right. I'll ask questions as we go.
I was thinking more the Solomon case.
Yeah.
Does GIS get used subsurface? And I know I see reef.
Yeah.
Does it do, I don't know if oceanography is the right term.
Yeah, right.
Does it do sub-water level and subsurface? Because
Yep.
everything that I've seen is kind of
Yep.
ground level up.
Soils, geology.
Volcanic sort of stuff.
Yeah,
Does it get used
yeah.
for that?
Anything spatial. Bathymetry.
I just wasn't
So,
sure.
yeah, I guess, no. And actually, if you think about it, the world is a three-dimensional place. So actually, GIS is moving much more towards three-dimensional representation. Typically, it's been a two-dimensional thing. So you would But it's
There's a different database.
no, it's the same. But so I think it's moving that way, and everything will be represented as three-dimensional. So you can represent anything in three-dimensional space. I mean, in some way, I mean, you can use GIS to represent things in the atmosphere as well, not on the surface. So yeah, yeah, certainly, yeah. I guess some of the examples I'm using are just surface because that's what I work on. But yeah. Yeah, no, you can. Yeah, so people use it to represent seagrass, reef, and so on that are underwater. Yeah. Yep. So recent work we've done takes this information and then tries to, on a different model, but uses it then to look for priorities across regions. And these are some examples of different actions prioritized across New South Wales that the New South Wales government are using to develop conservation strategies for koalas. So there's, you can use that then to try to inform policy. These are again using GIS to visualize those. I'm not going to go into it too much, but I think the darker the color, the higher the allocation of funding to different areas. So we can use that to then look at priorities. And then the last case study I was going to show you was really something different, slightly different, which is really, and GIS is often used for planning. So this is an example of urban planning. And so if you, and really a nice illustration of how GIS can be used interactively to provide tools and visualization to people. So this is the city of Perth, and they have an online interactive map showing the planning, essentially the planning scheme. So I think see if I can try and link to it. Sorry? No, this is the whole of the city of Perth. Yeah. Hang on. I'll just try and get back to the. So if you go into, you can have if you're interested, you can go and have a play around with this. It's a bit slow. But essentially it's an interactive map. So it's got the city of Perth, and then you can query that map. So underlying this is a bunch of GIS layers, and you can, you can add, so you can actually query, yeah, so we can zoom in a bit. So you can query individual parcels, so you can click on, so these outlines are the locations of property parcels, and you can click on those, and it'll give you a whole lot of information about that parcel. So it gives you the use area, that's 10 residential. It'll give you the precinct area, so there's a code there, and then it gives you information such as the size. Maybe you can't see that if you're too far away, but anyway, it does give you the size of the property and so on. And then you can add other information, so you can add layers. So if you go over to here, no, hang on, not that one. I'm looking for this one. So I think you can, so we might go maximum building height. So we might have someone might be planning a redevelopment and they want to look at, well, what's, different areas, what's the maximum building heights? So we can add different layers and then query those again. So in this case, that's just a random property. And then this gives you the maximum building height. It's not very, it says, refer to Terrace Road design policy. So there's a policy you can go and refer to. Actually, some of them do specify an actual height, if I can find one. Maybe over here. No. Yep. Maybe I got the wrong layer. Anyway, there are some layers in there you can specify, you can ask to provide the maximum building height. Maybe I picked the wrong layer. But anyway, my point is that this is a really nice example of an interactive map that actually allows you to query the map. So rather than typically, a paper map, static map, really we've got a very interactive map here. So a nice example of the use of GIS to communicate information spatially. Okay. So those are sort of just some examples that hopefully give you a bit of a sense for how GIS is used in the real world. Lots of fundamental questions and decision making. So we're going to have a little bit of a discussion now, but what I want you to do first is I guess I just wanted to, so I'm going to go on and talk about the course in a minute, but I just wanted you to get a sense for what disciplines people are interested in. Actually, before we go on, any questions about that stuff, about GIS? Everyone got a rough idea of what GIS is and how it's used? Yeah? Okay, good. So when you go, we're going to do a bit of a word cloud thing here. So if you have access to the web, go to this location. You should be able to just put in a word. And so I want you to describe what discipline you are studying. So I'm going to get a bit of a sense for where people come from in terms of disciplines. Hopefully this will work, and I'll try and link to it in a minute, and we'll see what people say. So if you do have access to the internet, if you don't worry about it too much, as long as we get a bit of a poll of people. I'll try and link to it now. Does it work? Oh. Should be word cloud. Does it work? Hang on a moment. Okay, you should be okay now. Sorry. I think I had it closed. Oh yeah, it's working now. Oh. Okay, we got some answers. Okay, so that gives us a bit of a sense, I think. So, and I'll give you a bit of a sense for who else is in this course. So, I guess we got some conservation people, people doing urban planning and geography, environmental management, conservation, urban planning. So, quite a lot of people doing urban planning type stuff. What else? Is anything different there? Mineral resources, information gathering. Looks like my Bradley. Okay. So it seems to be an emphasis on sort of conservation, natural resource management, environmental management, and urban planning. Sort of environmental theme, mainly perhaps. Marine and mineral resources. Okay. So hopefully that gives me a bit of a sense for what you're all interested in. But what I want you to do now, for for 5 minutes in your groups. I want you to, if you don't know each other, introduce yourself. So everyone gets, so a bit of a, so if you do know each other, that's fine. I know some of you will know each other. But I want you to discuss, well, what do you want to get out of the course? And I want you to, someone from each group, so do that for 2 or 3 minutes. What are the 3 things you might want to get out of this group? From your group. What are the 3 things your group might want to get out of the course? And you can come and I'll give you a pen, and I want you to just write those on the board. So I guess I want you to think about what is it you want to get from this course in terms of GIS skills, insights, critical thinking of spatial analysis. So do that, but introduce yourself first and let everyone know who you are. So do you want to do that? We won't do that for very long, but it'll just get you start thinking about what it is you want to achieve in this course. And then I'm going to talk about the course a bit. So we'll do that for 5 minutes. I'll bring around a pen. Plenty of whiteboards around. Just pick a whiteboard and write down 3 things you want to get out of the course. And that'll be good for me to understand what you want to get from the course too. Yeah, so when you've decided on 3 things, just grab a wall somewhere and write something and... Oops. You can write more than 3 if you want. Oops, sorry. Cool. Good luck. we can try. Good job. Oh, sorry, did I not give you a pen?
No,
Oh, no, sorry. I didn't make it over. Sorry. Yeah. Okay. I think all the groups have written something. So I'm just looking at the thing. So I guess a common one seems to be learning software, learning to use the GIS and a bit of how to do that. So problem solving, I think this is something we will focus a lot on, is problem solving and asking good spatial questions. So one of the things we will focus on in the course is well, how do you think spatially, and how do you ask the right question, and how do you plan to answer the right question, and how do you use GIS to do that? So I mean, a lot of that's conceptual and practice in learning GIS, and I guess that comes into sort of applying to projects. How do you develop a project in a GIS? And so some of the challenges of GIS is asking the right question, but then knowing how to, once you've asked the right question, how do you answer that question with GIS? And we will focus a lot on that. I think there was, using school analyzing data. Yep. So refreshers for previous courses, GIS courses, and applying skills to specific industries. So I guess we will, it's not completely exhaustive, the types of applications we consider, but hopefully it covers a range that keeps everyone happy. And I think there's some stuff on sort of, collecting spatial data. How do we collect spatial data? So we'll develop some skills. We certainly will develop some skills around that, and mapping as well, and communication. I think a really useful, a really important role for GIS is communication. So we do focus on a bit on that. And so how do you communicate spatial data effectively and concisely? So I guess fundamentals of GIS. How to use a program. We've got over here modeling and analysis. So I guess there's a bit on analysis. And I think the career stuff's important. I think GIS skills are really in demand for a wide range of industries. I think it's becoming much more commonplace for GIS to be integrated into industry and companies' operations. So that's it is a skill in demand. So we will, try and relate where we can to industry and careers. But if anyone has any questions about careers and using how you make the most of your GIS in your sort of career development, then I'm happy to discuss that. We could even have a session on that if you want. Someone's going to stop Queensland land clearing from this course, so that's a challenge. So, well, let's try. I don't know whether we'll get very far, but we can try. We can try. Okay, that's good. I think hopefully I don't know whether there's anything else that I missed, but I think that covers the main things. Yeah. Okay. Well, that's useful. Good. Yeah. And so I guess there's a few more specific things as well. Okay. Now I'm going to tell you what I think we're going to do, and hopefully, and I think the idea of the course is to address many of these things. So really, I guess the main aim of this course is to really introduce those practical methods and concepts for applying GIS to both mapping and analyzing. So mapping, I always think of communication. How do you communicate data to people? And mapping doesn't necessarily just mean a static map. It can be interactive maps. And analyzing geographic data. And I think a lot of what we do, there's quite a lot of conceptual stuff in the course. It's not only just about, and I wrote down here, it's not a computer software training course, and it isn't. You will learn aspects of the software, but it's not going to be exhaustive, and we try not to just say, click that button, click this button. It's actually really trying to get you to think about the problem. And obviously, we have to do some of that, press this button and press that button, especially in the first few practicals that we do. But that's, overall, that's not the idea. So it's not, actually, although we do teach some of the software, it's not a software training course per se. It's about spatial thinking, solving spatial problems, a lot of the concepts of GIS. And then some, a large focus on practical elements. But we don't teach every aspect of the software, and some of it you will need to try to develop that understanding yourself a little bit. But anyway, we can talk more about that. But it's not. And I guess it considers GIS across a broad range of disciplines, and I've listed some here. Physical and human geography, environment and conservation sciences, planning. And earth sciences are sort of some of the disciplines that we may consider in the course. So that's sort of the aim. And hopefully by the end of the course, you'll come out with a good understanding of spatial thinking and how you use spatial thinking to solve problems and understand environmental or human processes or geological processes and so on. And also an ability to apply that using GIS to answer those questions and some practical skills in actually using the software. And how do we do this? So I guess one thing I should say, it's as I said earlier on, it is a compressed course, and I'm going to show you the structure in more detail here. But so that brings its challenges, and it also brings its benefits. I think one benefit is that I suspect most of you are probably not doing other courses at the same time. And we're doing something every day. So actually one benefit is that you're sort of immersed in doing it, and I think the learning process can be much quicker. If we're doing a semester-long course, we tend to go from, we see students once a week, and by the time they come back the following week, they've forgotten what they did in the previous week. So, and because the course does build on itself, you sort of have to, you're taking 3 steps forward, 1 step back. But I think, being a compressed course, that doesn't tend to happen. You're sort of, you tend to build on that quite well. But I mean, the challenges are that it is compressed, and so learning a lot in a short time is difficult. So I try to, rather than just giving you lots and lots of information, try to break it up, the lectures into activities and so on. So I'm not just talking at you for 2 hours. That's what I'm. In the lectures, we'll aim to do that in terms of having short stints of material, and then activities in between. So we understand some of the challenges, and I'm happy to talk more about that later. But essentially, so I guess we've got 3 weeks. We've got 3 weeks of content. And so do have a look at the course profile. There's all the activities that we'll undertake are in there. And maybe I'll try and bring that up in a minute. But so really, I guess the first 2 weeks really are really focused on concepts, data visualization, and data analysis. So really, these are the building blocks of GIS. And we'll have a bunch of lectures. As I said, I'm not going to try and talk to you for 2 hours during the lectures. We'll try and do some activities. We'll have practicals. So we have these lectures every day from 9:30 to 11:30. And then straight afterwards, we have a computer practical in the lab. Actually, what I should say, I should have mentioned earlier in the lecture, there is a sign-up for the practicals because we're going to run 2 pracs simultaneously because of the size of the class. So you do need to sign up for a prac. I was told last week that they could only open the sign-up this morning, so I think they opened it at 6 o'clock this morning. So do make sure you sign up for one of those. If you can do that before the start of the prac today, that would be good. So I think you should just be able to sign up through MySignet. Okay. If you have a problem, let me know. So there'll be practicals every day, except for this. So that's during the first 2 weeks. And so essentially what the practicals will, I'll talk about this a bit more in a second, but essentially the practicals will follow on from the lecture. So the topic of the lecture will be the topic of the practical. We'll have a field trip. So you're going to work on a project during this course, and we'll have a field trip on Friday. And I'll tell you a little bit more about that in a moment. And really the idea of the field trip is to start you thinking about the project and start collecting some data for that. And then some assessment. So we'll have in-class quizzes. So I'm going to do each lecture. I'll do this. I'm not because I don't want to talk to you for a long time. We're going to have some quizzes. This is not assessed as such, but I've just got some audience response devices, and we'll have some quizzes on just 5 questions, just to kick the lecture off with asking some questions about the topic of the day before. And so the idea of this is just to allow you to sort of refresh your memory from the day before, and also resolve any issues or misunderstandings that may have occurred. So we can look at people's results and have a discussion if there's any misunderstanding. So we'll do that. That usually takes about 15 minutes at the start of the lecture, and we'll just do that first off in the morning, and that's usually useful in providing some feedback on people's understanding. That doesn't go towards your assessment, so it's a non-assessed assessment, if you see what I mean. That doesn't make any sense at all, does it? But you know what I mean. Doesn't count towards your mark. So in-class quizzes, and there'll be practical exercises. So there's if you go on to, actually I'll show you now. So if you go into Blackboard, under Assessment, under Practical Exercises, there's a description of the practical exercises. So there's 2 practical exercises, one due on the 27th of November, and actually that should be Monday. I'll fix that. I think that. Yeah, I'll fix that. The date's right, but the day's wrong. Next Monday, and then another one the following Monday. And basically, I think practical 3 and 4, there's a question at the end that you need to answer, and then submit the answer to those questions by the following Monday. I think that's this. So the practicals from this Wednesday and Thursday. And then there will be 3 questions the following week, practical 6, 7, and 8, then to be submitted the week after. So there's only a small weighting attached to these practical exercises, but the idea is to get you thinking about what you've done in the practicals. So the description of the assessment is there with the marking criteria. So that's the assessment really in those first 2 weeks. So the third week is really trying to bring it all together. So it's taking the concepts, you'll sort of learn the building blocks, and then that third week is is really trying to bring all of that together. And again, we'll have lectures, but I think we've only got one lecture in that third week, right on the Monday. We don't have any more lectures after that third week. We have practicals. So practicals, essentially, you'll be working on your project. So you'll be working on your GIS project. And then the assessment is a project report and an exam on the 8th of December. So I'll tell you a bit more about that in a second. So this third week is really focused on trying to integrate what you've learned into, and this idea of actually using it to ask a question and use GIS to answer that question. And then there is a fourth week, but there's no classes. So that fourth week is essentially the GIS report is due at the end of that week. The labs will be, GIS labs will be free. You can use them, but really that's your own time to work on your project. I know some people have said they're going to disappear. I think they've emailed me and said they might disappear after the third week. That's okay. You can do this remotely and submit remotely. But I guess, yeah. So I think that you're not required necessarily to be here, but you will need access to the GIS software to be able to complete your project in that fourth week. Okay.
Software do we need? Just the
Right.
software to choose from.
Ah, is there?
Yeah.
What are the choices?
ArcGIS 10.3.1, 10.4.0, or 10.5.0.
We'll check which version they've got in the labs, because it's probably best for you to choose the same one in the lab. So when we go over to the labs, we'll have a look and see which version it is. Sometimes if it's different version, I would say get the latest one. I suspect they've got the latest one, 10.50 in the labs, but you should just check if you got. So you want to so then you can switch using data in the labs and your computer. So just check. We'll check in the labs what version it is. Yeah.
Do you know if there's any issues running ArcGIS on Mac versus PC?
You can't run it on a Mac. So I think people have got around it before by installing Virtual PC and running it. It is possible. It's a bit of fiddling around, but it is possible to do. I think I'm pretty sure you have to run Virtual PC to get it to install that, and then you can install ArcGIS. Yeah. I don't know why they haven't produced a Mac version, but they haven't. So you'd think there'd be demand for it, but anyway, they haven't. So yeah. So if you got the message last week about getting the software, if you do want the software for your own computer, then it is available. I think I sent a link around in an email, but if you're stuck and you can't find the email or anything, just do a search on UQ, type in ArcGIS, and I think it will come up with a link to the software, and then you have to get an authorization code. And I think it's once you install it, it'll be valid for a year, so you have a year's use out of it. Okay. Yeah. So I think most people will probably want to do that. Okay, so that's an overview. I'm going to talk a little bit more detail about lectures and so on, and assessment, or maybe the assessment is perhaps the most important thing for now. Anyway, so lectures, as I said, they'll be here, 9:30 to 11:30 each day. Again, have a look in the course profile for the exact dates. So in that last week, I think the third week, there's only one lecture on the Monday. And then after that, it's free time. We'll continue with the practicals, but there won't be a lecture. So I don't know, not much more I'm going to say about lectures. As I said, we'll have a quiz each lecture, and we'll try and do some exercises rather than just me talking to you for a long time. What I would say, though, I mean, I know it's a compressed course, but I think I'm not going to give you huge amounts of reading to do, but I would encourage you. There will be a reading associated with each lecture, largely from the textbook, and I'll talk about the textbook in a moment a little bit more. So do the reading. I think it'll be, if you can, it should only be, I suspect, an hour or so of work to do the reading. I'm not going to overload you with reading because I know it's a short course. So, but I think whatever the chapter is that I suggest reading would be important, and I mean that's important for you to get a more solid understanding of some of the concepts. I mean, the lectures will focus largely on concepts rather than application, and we will show examples of applications, but it's not getting your hands dirty and actually doing GIS in practice, but it will be about concepts and applications. And so So I think and doing the reading will help with that. And I think given that there's a small exam on the 8th of December, and so I think that'll be some of the preparation for your exam as well, rather than don't leave all the reading to the last, the few days before, since we don't have, you don't have a lot of time. Okay, so I think if you can get in the practice of doing the reading each lecture, if you can do it before the lecture, that's probably better. So if you can find, an hour in the day after the practical and do the readings before the next lecture, that would be beneficial, and I'd recommend it. So there will be a lecture. I think I've put the practicals up a week before on Blackboard. Sometimes I fiddle around with the lecture the day before, so I'll probably put the lecture up the night before the lecture on Blackboard. Yeah.
Are we having our exam in this room?
I'm not sure where the exam's going to be yet. It'll be at this time at 9:30. So it'll be. I'll say a bit more about the exam in a moment. I don't think it's going to be in this room because it's not really set up for exams. It'll probably be somewhere else, but I'll let you know. Yeah. I think they've booked something, but I haven't been told where it is yet. Sorry? It's a 1-hour exam. Yeah. So it'll start at 9:30, but it'll be over by the time we get started. It'll be over by 11. Yeah. And then we'll have a prac as usual afterwards. Yeah. Okay, practicals. So the practicals are really the component of the course that really focuses on developing the hands-on skills. We'll use the ArcGIS software. So most of the practicals, you're given a set of data and a guide, and essentially the idea is to work through the guide. Within those guides, there are questions that you need to think about, so it's really prompting you to think about what you're doing. And I think the first few practicals are very much just getting you used to the software. Like today's practical, for instance, is provide you with some data, show you some basic stuff about ArcGIS. What's the structure of the software? What are the different components? How do you just load some data in? How do you visualize it? So that sort of stuff. So today's practical is at that level. And then once we get more into the course and when you're working on your project, there's some guides associated with the practicals, but they tend to be less. They're more. It leaves it more open for you to explore the software yourself. Okay, so I would say really important to attend the practicals. It's the place where we help you with the practical stuff. We're in 2 rooms. There'll be myself and then 3 tutors, Sarah, Valentina, and Mo, and I'll introduce them to you once we go over there. And so really, I think it would be very difficult to do the course if you don't attend the practicals, because that is the time when you get help with the practical components. And really, putting the stuff you've learned and the concepts into practice. Okay, so I would stress the importance of actually going to the practicals. Okay, so I don't know what else I want to say about practicals. One other thing. So you'll work in the labs. What I would recommend is that you probably the most easiest thing to do is work off an external hard drive or a USB drive. If you're going to use to put your data on, because although you have your own student storage on the network, it's not very big. I don't know. You can buy more space. I know that, but I think the standard amount of space is pretty small. So you're probably better to work from a USB drive. But I would recommend if you're going to have a USB drive that's at least 8 gigabytes. Otherwise, because you will be putting a reasonable amount of data on there. So my recommendation is, something around 8 gigabytes at least would be the minimum. I can talk about that again in the practicals, but so bear that in mind. Okay. So is that okay? Is that clear about practicals and lectures? Any questions about that? You know where you need to be when? Yep. And all the material for lectures and practicals are on Blackboard. So you can just, when you get into the practical, we'll do a bit of an introduction, but then the material's there for you and the work guide to work through is there. Okay. So one of the things I like to do on this course is take everyone out into the field and do something useful and sort of a bit, something that's fairly real world. So we actually, in the project, you actually do a planning exercise. So you use spatial data to do some planning exercises, a planning exercise. But to support that, we do a field trip. And so where you'll do this planning exercise, really a spatial sort of planning exercise is this place out here. This is a UQ property. It's down the river in Pinjarra Hills. And I'll tell you a bit more about it on the field trip, but it's a property that's had the vet school on until quite recently. There's a whole load of other things that they've done there. I think it's about 300 hectares in size, and we can go there and freely use it. And it's sort of quite unique for that part of Brisbane. A lot of the area around has been developed, and this is a lot of it's been cleared of vegetation, but it still has quite high environmental values compared to a lot of the urban areas of urban development around it. But at the same time, a lot of it's been degraded environmentally as well. So I think it's a nice opportunity to go and think about how you might use the landscape and use GIS to do that. So I'm not going to tell you too much more about that now, but I will over the next week, and on the field trip we'll tell you more about that. So I think it says on the course profile that it's compulsory to go. It's not strictly speaking. If you really can't go, you'll be okay. but I think it's really important that you do go, because we will collect data, and you will need that data for your project. So if you don't go, it's a pain, and you won't have the data you need for your project. So it is important that you go. It's going to be about a half a day. We'll leave. We'll leave it. I was thinking about 7 o'clock, but I think that's too early. I think we're going to leave about 7:30 in the morning. So it's going to be an early start. And the reason, if we go later, it just gets too hot this time of year. It's possible it could be a cool day, but I've been out there before where it's pretty hot, and we're going to do a bit of field work. So we'll leave about 7:30 from the pool area. I'll send an email around to confirm this, and then we should be back at UQ by 2 o'clock. So it's really a half day field trip. If you have an issue with getting to UQ at 7:30, then let me know. But that's the plan. We'll just get a bus from outside the UQ pool. Any questions about that? I'll send some more details around in the next couple of days. One thing you can do, so we're going to, if you've got a mobile phone or tablet or smartphone, then you can download this ArcGIS Explorer. So I'm going to make some data available. ArcGIS Explorer allows you to import layers and visualize those on your mobile device. So there is an app for an Apple app or an Android app as well. So you can download that. We'll have some data layers that allow you to interpret or at least visualize that when you're at the site. So it's GPS enabled as well, so you should be able to see where you are. If you don't have that a mobile phone or tablet that you can load an app onto, then that's okay. We'll have some maps as well. But I'll let you know about that in terms of how to access the data in the next day or two. So the idea, if you've got that, then download it. I think you can use it without an Esri account, but you may need to create an Esri account. But it's essentially free. It is free. Okay. So if you're able to download and install that app, then do so, and I'll send some more instructions in the next couple of days. Okay. Any questions about the field trip? Concerns? Happy? Okay. All right. And it's not far away. It's only about a 20-minute drive. So, okay. Assessment. So assessment's important. You will need to know what you need to do for the assessment. And so there'll be a bunch of, as I said, a bunch of in-class quizzes, 5 questions a day associated with each lecture. It'll just be quiz from the week, from the day before. I'll bring some little clicker things and I'll distribute them tomorrow. And so there's no waiting on that. It's really just feedback and I guess providing you some feedback on how you're going with your understanding and the course. That's the idea. So practical exercises. These are associated with each practical. Some of the practicals. There's 5 questions in total to answer, with a total weighting of 20%. And there's two questions due on the 27th, and 3 questions due on the 4th. And if they have slightly different weights, at 8 and 12% weight, but that's because there's different numbers of questions, so it's basically 4% per question. So it's a low weighting, but an important part of the course. Yep.
Are they all online?
Yeah, what you do, there's a couple of questions at the end of the relevant practicals, and just put it into a Word document and you'll submit through Turnitin. Does that make sense? Yeah. So you just put your answers into a Word document and then submit them. Yeah. So you don't need to submit each individual question. Just submit 2 questions on the 27th and the answers to 3 questions on the 4th. Yeah. And then the third piece of assessment is the report, a paper on your GIS project. It's there's quite a large weighting, so this is the bulk of the weighting for the course goes on this report. And the reason for that is that this is where you demonstrate you can integrate the concepts of GIS and to answer a real-world problem. Okay, so that's it really examines your ability to do that and ask the right questions and be able to bring together different types of analyses to answer a specific question. I will circulate probably in the next week or so, the description of that project, and we'll talk more about what you need to do for it on Friday. But it's a relatively short report. It's sort of 2,000 words, so it's short, but it has quite a reasonably high weighting. And that's due on the 15th of December. So that's a week after the exam, basically. So you basically you'll be working on it in the 3rd week, but then you'll have time, another week, to finish off that GIS project. And then there's an exam, as I said, on the 8th of December. There'll be 8 short answer questions. So these are questions that are relatively short. There will just be a few words or a paragraph answer to those questions. So they are short questions, and that'll be on really the concepts that we've talked about in the lectures. So concepts and applications in the lectures. It's 1 hour exam, yeah. 8 questions, yeah. If you go on Blackboard, there under assessment exam, I've put all the previous exam questions on there, and I haven't put last year's up yet, but I will do. So you can see some years I've changed the number of questions, but I think 8's about right for an hour. I did 10 one year, and it was a bit long. I was a bit harsh to those students, so we've gone back to 8. So anyway, I think that's about right for an hour. Yeah.
Is the content of this course similar to past years, or has it changed significantly?
No, it's pretty similar.
Yeah.
Yeah. I mean, the overall content hasn't changed. We've changed a bit of the delivery, but not.
The past exams are rigorous.
Yeah, in the main. Yeah. But if you see something, I don't know, there may have been I can't remember. There may have been 1 or 2 things we've taken out or put in the course, but it should be pretty obvious which ones. Yeah. So just on that assessment, there's a hurdle. You have to achieve at least 40% in the exam and 50% overall across the assessment. So just bear in mind there is that hurdle on the exam. So if you did really well on all the the coursework stuff and thought you didn't need to try hard at the exam, then you need to make sure you get 40% in the exam to pass the course. Does that make sense? That's probably pretty common across courses now. Yep. But that details there on grading and assessment criteria are in the course profile. So do look at the course profile. So learning resources, then everything will go on Blackboard. I'll communicate through Blackboard. Lecture slides and guides to practicals will go on Blackboard. I'll talk about the course text in a minute, and there's some web resources on Blackboard as well. If you go to, I've got Blackboard up. Yeah. So there's a few. I mean, we have information on lectures, practicals, field trip, the assessment, and then London Learning Resources. There's just some links to some additional stuff about GIS. There's a DI dictionary. What was I going to say? So anyway, so there's resources on there. And then the last thing I was going to say before we wrap up is the textbook. So I do use this textbook, and we don't use it for every lecture, but usually there will be a reading from this textbook. You can buy it online. It should be in the Co-op bookstore. There are a few copies in the library. They're all gone. All right. Okay. I must hassle them to get some more actually, because I think we do use it for a few courses. Yeah. Right. Yeah. Okay. So they should be in short-term loan, I think, and so that's an option. You can borrow that one and photocopy things or scan things. So if you can't, I'd recommend you buy it. I mean, I think it's about, I don't know how much it is. I think it's $70 or $80 or so. So it's not the cheapest book, but I think online it's about 60, maybe. Anyway, I'm not sure. But I think it's sort of one of the better books that I've found. I mean, it sort of has its limitations, but I think it's not bad for a book that covers GIS. If you really can't get access to the book, there is an alternative book which is free called, and I've listed it under Learning Resources, Essentials of GIS. It's okay, but it's probably not as good as this book. But if you really can't get access to the book, then there are sort of, not always, but sort of equivalent chapters in that book. Okay, so now what I've done, I've put the PDF under Learning Resources as well. So that's another resource you can use. Okay. Okay. So we're going to finish up. Any questions?
I saw that on the lectures that you recommend us to read two books. One is this one and the alternative textbook.
Yeah, often I do.
Should we read all of them or just one?
You can read both if you want, or you can, you can. So what I'll try and do is I will, if there's a chapter in this that is equivalent in the other textbook, the alternative, I'll recommend it. I mean, it's best to read both, but I think the primary reading I usually give from here. But if you don't have access or can't get access to it, then read the alternative one from. But if you can read both, all the better. Yep. Okay, so we're going to go to the labs now, and so yeah, if you do get to sign up before you get over there, I know it's a bit last minute, then that'll be good. So I think that we're over in the Chamberlain building, which is not far from here, that way somewhere, and we'll see you there in about 10 minutes or so. Okay.